Hey everyone! Today, I'll show you how to nail the perfect scale for any physics graph in just 5 simple steps. Whether you're a student or a teacher, this is for you. Step 1. Identify and round up the maximum values of your readings or data values. For example, if we use the table of values shown, taking t as the vertical axis and root L as the horizontal axis, we can round up the maximum value of t to 2.00, that is 1.925 becomes 2. For root L axis, we can round up the maximum value of root L to 9. We can just make it 10, instead of 9, because 10 is easier to work with. Step 2. Determine the graph paper limit. This means finding out if your graph paper can accommodate your readings or data values. For example, let's say this is your graph paper. From one thick line to the next is 2 centimeters or 1 box. For the vertical axis, we are limited to just 12 boxes or 24 centimeters. That is 1, 2, 3, 4, 5 till 12. For the horizontal axis, we are limited to 10 boxes or 20 centimeters. That is 1, 2, 3, 4 and so on till 10. Our objective is to select a suitable scale that can accommodate our data values. How do we do that? Let's talk about that in Step 3. Step 3. Calculate possible scales. Different scales can be used for your readings or data values. To calculate a possible scale, divide the maximum data value by the available divisions. For example, for the vertical or t-axis, a possible scale can be obtained by dividing 2, which is the maximum data value of t, by 10. We use 10 for the division, instead of 12 on our graph paper, because 10 is easier to work with. Dividing 2 by 10 gives 0.2. This means a possible scale for the t-axis is 2 centimeters represent 0.2 unit. You can do the same calculation for the horizontal or root L axis. Doing this involves dividing 10 by 10 to get 1. So for the horizontal axis, a possible scale is 2 centimeters represent 1 unit. When selecting a suitable scale, please go with numbers like 1, 2 or 5. For example, 2 centimeters represent 0.1, 0.01, 0.2, 0.02, 0.05 and so on. These numbers are easier to work with when graphing. Step 4. Label your axes clearly. It's time to draw your graph. First, draw your vertical line, such that you will have 10 boxes when you count from the line. Secondly, label the vertical axis. In our example, we take t to be the vertical and s to represent the unit of t. Thirdly, draw your horizontal line, such that you will have 10 boxes when you count from the line upwards. You can skip 2 boxes before drawing the horizontal line. Fourthly, label the horizontal axis. In our example, we take root L to be the horizontal axis and root centimeters to represent the unit of root L. Your graph, after labeling, will look like this. Step 5. Ensure uniformity. Recall, for the t-axis, our scale is 2 centimeters to represent 0.2 unit. This means, we count in 0.2 as shown. So 0.2, 0.4, 0.6 and so on. With this, we can accommodate the smallest data value, which is 1.41 and the highest value, which is 1.93. We do something similar for the root L axis. Recall, our scale for root L axis is 2 centimeters represent 1 unit. This means we count in ones. That is 1.0, 2.0, 3.0 and so on. The graph before you plot will look like this. This shows 2 centimeters represent 0.2 seconds on t-axis. And 2 centimeters represent 1 root centimeters on the horizontal axis. And there you have it. If you found this helpful, don't forget to like and subscribe for more tips like this. Thanks for watching, and happy graphing!